The Royal Swedish Academy of Sciences just announced the Nobel Prize for Physics for the year 2024. The prize was awarded to John Hopfield and Geoffrey Hinton for what it says, and I quote, foundational discoveries and inventions that enable machine learning with artificial neural networks. The prize is mainly attributed to their works on Hopfield network and Boltzmann machines. A Hopfield network is a form of recurrent artificial neural network popularized by John Hopfield in 1982. It is an associative memory network where information is not stored locally at one point but is spread over many neurons, possibly similar to the memory in our brains. Its main advantage lies in its ability to recall or recover patterns or information even if it is corrupted by some amount of noise, and therefore it found its application in facial recognition and other image processing tools. The way it reconstructs the true image from the corrupted version is by trying to minimize the energy function. This energy minimization is a standard optimization problem almost as old as differential calculus itself. Even in modern machine learning, the gradient descent algorithm does exactly this. Such Hopfield networks consisted of a single layer of neurons, each interconnected with each other, and energy is dependent on the binary values on each node and the weight of their connection. The model learns the weight of connection from the training samples and applies it to correct the node values of the test pattern. Geoffrey Hinton further developed this idea by including additional hidden layer or layers which doesn't directly take any input or give output but still contributes to the overall functioning of the system, very much like the deep neural networks of today. They both made further improvements and progress to the neural network systems, which eventually led to the MLA revolution of today. So, the most debated question of today is, what does any of it have to do with physics? To understand that, we need to look at a bit of history. The Ising model, named after the physicist Ernst Ising, is a mathematical model of ferromagnetism in statistical mechanics. The model consists of discrete variables that represent magnetic dipole moments of atomic spins that can be in one of the two states, either +1 or -1. The spins are arranged in a graph, usually a lattice, allowing each spin to interact with its neighbors. The neighboring spins that agree have a lower energy than those disagree. The system tends to the lowest energy, but heat disturbs this tendency, thus creating the possibility of different structural phases. The Ising problem without an external field can be equivalently formulated as a graph maximum cut problem that can be solved via combinatorial optimization. In the Hopfield model, the neurons interact with each other similar to that of the interaction between the magnetic dipoles. In 1982, John Hopfield introduced an artificial neural network to store and retrieve memory like the human brain. Here, a neuron is either firing on or is off, not firing. The state of a neuron, for on it is +1 or off is -1, will be renewed depending on the input it receives from other neurons. He considered these states similar to two different spin states of the magnetic dipoles considered in the Ising model. John Hopfield studied and worked on condensed matter physics and statistical mechanics, which inspired him to model his neural network. Later, he shifted his focus to molecular biology and neuroscience, and he found this model useful in devising a mechanism for the memory in brain. So that was about John Hopfield. But Geoffrey Hinton, purely a cognitive psychologist and a computer scientist. How did he come in fray of Nobel Prize for Physics? His works increased the applicability of the Hopfield networks, and probably without them, the works of Hopfield might have had a lesser impact and slowed down the AI revolution. So even though the works were not so much in physics, it definitely amplified the social impact of the science rooted in physics, which is as important, and the development of the underlying physics itself. It is also to be noted that the Ising model of a neural network as a memory model is first proposed by William Little of Stanford University in 1974 by his paper titled The Existence of Persistent States in the Brain, which is the same idea behind Hopfield networks. Such associative model memory models are further based on what's called Hebbian rule. The Hebbian theory is a neuroscientific theory claiming that an increasing synaptic efficiency arises from a presynaptic cell's repeated and persistent stimulation of a postsynaptic cell. It is an attempt to explain synaptic plasticity, the adaptation of the brain neurons during learning process. It was introduced by Donald Hebb in his 1949 book, The Organization of Behavior. The theory is often summarized as cells that fire together wire together. In the mathematical model of Hopfield network, they appear in the form of weights of connection between the different neurons. As you can see, the development of machine learning and artificial intelligence involved condensed matter physicists, molecular biologists, neurologists, mathematicians, and computer scientists. And today, it has a massive application in medical diagnosis, physics, and pretty much every other field of science. So, let me quote another line from the Nobel article. Because physics has contributed tools for the development of machine learning, it is interesting to see how physics, as a research field, is also benefiting from artificial neural networks. Machine learning has long been used in areas we may be familiar with from previous Nobel Prizes in physics. These include the use of machine learning to sift through and process the vast amount of data necessary to discover the Higgs particle. Other applications include reducing noise in the measurement of gravitational waves from colliding black holes or the search for exoplanets. The progress in AI, especially in the last year, was so incredible that it has become an integral part of our lives of each of us. It is again reflected in the Nobel Prize for Chemistry, which also went to the contribution to the area of artificial intelligence. So, for me, the main takeaway would be the inseparability of various fields of sciences. Even as the research fields get narrower and narrower, the application and inspiration come from a wide range of fields. So, if anything, this should be seen as a call for cooperation and support among all scientific communities for the collective progress. What are your thoughts?